Hello everyone and welcome to this video. So in this series of 3 videos, we'll be looking at the questions related to base units and how you express derived quantity in terms of base units. And I've split this up into 3 videos because I think that you can group certain type of questions in certain type of categories. So right now we're doing the first type, and when you look at the questions, you'll know the type of questions that we're talking about, and the next one is going to be a slightly higher level type of question, and then the next one would be an even higher level type of question. So we're starting with this one. Let's start with this question. This is summer 2012 paper 1-2 question number 1. What is the unit watt in terms of SI base units? Now I know that watt is the unit of power, and the formula for power is work done over time or energy over time. Now let's say I do not remember the base units of energy. By the way, you should remember these because energy is one of those quantities that appears a lot in the formula for other quantities as well. I do remember it, by the way, and the base units for energy are this. But let's say for now I don't know that this is supposed to be kg meter square per second square, and if I have to work this out. So for energy, you can use either of the formulas, either half mv square or mgh. Let's say I use mgh, and this is divided by time. So mass is in kg, g is gravitational acceleration. So gravitational acceleration is meter per second square, right? Just like how speed is meter per second, so acceleration is change in velocity over change in time. So that's meter per second divided by second. That makes it meter per second square. H is height, which is meter. And then in the denominator, we have time, which is seconds. So kg remains as it is because that's the only one there. There's 2 meters. So basis the same, powers are added, meter 1, meter 1. When the powers would be added, this becomes meter square. And there's a s minus 2 here, and there's a s1 here. So when this 1 goes up, this would be subtracted. So minus 2 minus 1 makes it minus 3, right? So in base units, that's option C. Obviously, the unit, the order in which you write these bases does not make a difference. Either or is perfectly fine. Let's go on to the next type of question. What is the unit of weight in terms of SI base units? Alright, and now we can think about weight either in terms of this formula, and if you do this, or if you just say that force, that weight is just a force, and you can think about it in this way, both of these will obviously lead to the same answer, because as we just saw above, small g is acceleration, right? So mass is kg and g is acceleration due to gravity, so kg meter per second square, which is option B. Let's go on to the next one. Now this one is a bit more challenging just because there's more algebra, but otherwise it's pretty much the same type of questions. The unit of resistivity expressed in terms of base units is given by this. Which base units are x, y, and z? Okay. Now for this, you need to know the formula for resistivity, which was not in the O-level physics syllabus. So I'll just write this here for you. So rho equals R A over L, right? This is the formula for resistivity, R being resistance. And again, this is a more tricky unit that we do not know what the base units of this are right now, but we can work these out. So resistance, I can say, is voltage over current, but again for voltage I need this base unit as well, and voltage I can say is work done per unit charge. Now for the purpose of MCQs, if I remember the base units of work or of energy, so again that's going to make my life easy. So that is kg meter square per second square, and Q is the unit of charge. So charge is current multiplied by time, which is IT, right? So you're using the formula Q equals IT. So that's A S So if I solve this further, kg meter square remains as it is. The ampere comes into the numerator, becomes ampere minus 1, and this becomes S minus 3. And now I can plug this in here. So you have kg meter square per ampere per second cube divided by another ampere. So that is going to go into the numerator, subtract again, and that's going to make this a minus 2, S minus 3. And now for resistivity, this goes again into the numerator. So that is all of this that we just worked through. So kg meter square per ampere square per second cube multiplied by A, which is meter square, L, which is meters. So that means that this and this are going to cancel out like this, and what's going to remain is this. So kg would now become a meter cube, A minus 2, S minus 3, right? So kg, so m is 3, right? So x is basically meters, right? So that's this one. And then ampere, which is y, is minus 2. And then S is the Z, which is minus 3, right? So that's how you end up getting the answer for this one. Let's go on to another question. A slightly different type of question, very common in MCQs. That's this. So this says which quantity has the same base units as momentum, right? Now momentum, if I remember, momentum is something we have studied in O levels. So MV, mass is kg, V is meters per second. So I need to work through these and find out which one has the same base units. So let's say I start with A. So density is kg per meter cube, and energy is kg meter square per second square. Just here I'm going to stop, because this would make it a kg square, which is not what I have here, right? So it's definitely not this. Then let's do B. So B is density times volume times velocity. So density is kg per meter cube, volume is meter cube, and velocity is meters per second. This is exactly what I'm looking for. Why? Because the meter cube and the per meter cube cancel out to give me the same units here. The answer to this one is B. Let's go on to the last question. Another type of question very common in the MCQ paper. Which pair of units are not the same when expressed in SI base units? All right. Okay. So let's say I start with A, and by the way, there are a couple of ways to do this. One is that if you have a good grip on the formula of the quantities in AS, then you can also use that instead of just working through the entire formula and finding out the base unit. So you can do that as well. For example, if I look at option B, I know that Newton second and kg meter per second are both alternate units of momentum. So we just saw kg meter per second, and if you use that idea that impulse can be written as force times time, so this is a correct one, hence it's not the answer. And then if I look at pascals and Newton per meter square, again this also makes sense because power is force over area. So the derived unit is this, and a alternative way to write this is this. So this is also not our answer. And for these ones, I can work this out. So volts, we just did that above. Let me just go and see what that was to save time. So volts is kg meter square per ampere per second cube, right? Kg meter square per ampere per second cube per ampere per second cube. And then there's the Newton per coulomb, right? So this is this, and Newton per coulomb, let's do that here. Newton is basically the units of force, so kg meter per second square, divided by a coulomb, which is ampere second, right? So when we do this, you have kg meter remains as it is, and the ampere goes here, that becomes this and this, but these are not the same because there's a meter square here and there's just a meter here. So these are not the same, and this is the answer. With this one as well, these are the same. Again, you can work this out. If I write the Newton like this, so if I write the Newton as kg meter per second square, right, the units of force divided by kg, so kg's cancel out, and that is correct. Both of these are the same, so it cannot be this either, and the answer to this one is then D. So in the next couple of videos, we'll be looking at the more advanced questions where you have to find base units of a certain quantity using the same ideas. So I'll see you in that video now.